In this presentation, we're going to demonstrate how easy it is to network the OPC Systems.Net product features for remote connections. OPC Systems.Net utilizes a TCP/IP connection, so there's no Decom involved in the network connections, so that has many advantages for us. OPC Systems.Net implements the .NET frameworking built into the Windows operating system. It runs over TCP port 58723, so it's easy to get through your firewalls. Networking is supported over the Internet, wide area network, or your local area network. All OPC Systems.Net product features support easy remote networking. Also, remote configuration is possible either through the manual configuration tool and also the .NET components that are free to use for remote setup of OPC Systems.Net. We can also implement service-to-service communications. And by implementing a service-oriented architecture with queuing, we maintain a 100 nanosecond resolution, and data buffering is available so that there is no data loss on your network failure. By removing Decom, all of the components are then 100% managed, so you can implement smart client deployment if you like. We are going to demonstrate in this video how easy it is to set up the network connections. To define data points, you simply need to include either your network node, IP address, or registered domain name in the tag data source. We'll see how to implement this in the HMI controls for Windows, web, WPF, and mobile products, how to implement remote trending for both Windows and web applications, and also alarming for Windows and web applications. And we'll see how to programmatically access data remotely. Again, all of these features use the simple connection of using the network node name in the tag designation. We'll see how to implement OPC tunneling with the product features OPC Client.net and OPC Route.net to give you connections to both third-party OPC clients and OPC servers remotely. And we'll also review how to do remote configuration, even through a programmatic interface. Also, we'll cover how to do remote data logging, and alarm notifications. We'll see how to connect to remote database engines, but also how to connect to remote OPC system services as a data source. And at the end of this presentation, we're going to review the best practice to implement OPC networking. The easiest way is to use the features that we'll demonstrate in the first part of the video. OPC Systems.Net also supports remote Decom, but we'll see that by implementing remote Decom that you lose a level of reliability in that if your network goes down, you have lost the data. Also, by implementing remote OPC, we'll see that it's difficult to set up and difficult to connect to remote OPC servers unless you have the remote connectivity. And there is no support for internet connections when you're using Decom. And there is a Decom configuration guide. We'll point that out if you want to go it alone and use remote Decom instead of using the best practice of using the service-oriented architecture. Let's first demonstrate how to network the HMI applications to an OPC Systems.Net service. To demonstrate this, we're going to use Visual Studio. We'll use the OPC Windows HMI controls to show how to connect to a remote system. You could also develop a web application that could run also on a remote computer, and you would use the same networking principles. Also, the same is true with the OPC Mobile.net and OPC WPF. They would all have the same connection properties I'm about to demonstrate to you. Let's drop an OPC controls label onto the form. And we'll use the property text OPC Systems _tag to browse to the remote service. Instead of using the local service, we can enter in a network node name, IP address, or registered domain name in the network node box. You can also use the network browse selection to browse a local network node. I'm going to enter in the registered domain name opcsystemserver.com. When I hit the select button, I am now browsing the remote tags on a server in Texas over the Internet. I'll then select my tag and parameter that I want to connect to. Notice in front of the tag name we have the registered domain name opcsystemserver.com. I click OK, and that is all there is to it as far as networking to remote service. If you decide that later on you want to change the network node that you're connecting your tags to, you have two resolutions to this. Of course, Visual Studio supports a lot of great search and replace capabilities, but an easy solution is to use the network node control. Here we have the OPC controls network nodes component. You would integrate that just once into your application, and then you would implement the simple method called add network node alias on that component just once in the application, and it would redirect all communications from the original source to the new network node that you want to define to. We can use the same connection methods for trending. This is both for web and Windows trending. Let's drop the OPC trend control onto the Windows form. I'll just set the toolbar property to invisible so we can have a better view of the trend. Under the Pens property is where we're going to define what it is we're going to display in the trend. Again, instead of selecting the local host, I'll include either an IP address, network node name, or registered domain name. When we hit the select button, we'll see all of the tags that are available for trending. You can see that it includes the registered domain name in front of the tag name. If at any time you wanted to change these network nodes that it's connected to, you can right-click on your pen list and you could export them to a CSV file and re-import them. There's also a good example on how to programmatically define pens in the WinForm example source code. To network an alarm window to a remote service is just as simple. Let's drop in an alarm control. This is the same for both web alarms and Windows alarms. The web application can run remote on a different computer than the OPC system service. If the web application is running on the same computer as the OPC system service, the HMI, the trend, and alarm controls would all just use localhost in the connections, and then the client browsers would of course connect to that web application. So there would be no point in defining a remote network node when you're working with web controls when the web application is going to run on the same computer as the OPC system service. But for the Windows applications, you do want to include that remote node as we're doing here. I'll set the alarm toolbar to invisible to give us a little more space there. So to define an alarm window to a remote service, use the alarm network nodes property. We'll use the browse button. We can select the local service and include that, or define to a remote network node name. When we hit the select button, the add node button should appear. We can then add that registered domain name to the list of registered services. So in this example, we're connected to both the local service and a remote service, and you can include to connect to as many remote services as you like in an alarm window. I'm going to select the local service and remove that node, and now we're just going to be connected to the remote service. So now let's run this Windows application to see what the data results will be like. Here we see a live update of the HMI control, the trend control, and also the alarm window. Now when you go to deploy the application, it doesn't matter which client the application is running on, it will connect to the remote service as long as it has a network connection to it. If you wanted to programmatically access data from a remote service in your application, you would use the OPC controls data component. And this OPC controls data component is a headless component, so you can use it in a web application, Windows application, a Windows service, WPF application, any type of application that you can run on a Windows operating system, you can use the data component in. And you simply include the network node name with double backslash, network node name, IP address, or registered domain name, backslash, and the tag name, just as we have been doing in the HMI controls. If you wanted to connect to a remote OPC server over the internet from your third-party OPC client application, I would recommend to use the product feature opcclient.net. To implement this, all you need to do is install the OPC Systems OPC server on each of the clients and let it do the networking over TCP/IP connection back to the OPC system service. Let's demonstrate that from a third-party OPC client. I'm going to use the OPC Foundation sample client here. We could also use like the Kepware Quick Start client to also demonstrate this, or any of your favorite third-party OPC clients. We can select Browse from the OPC Foundation sample client. We're going to select the OPC Systems.net OPC server. It is both a data access 2.0 and 3.0 OPC server. And now what we'll do is we'll create a subscription to monitor some points. We'll choose an update rate of 100 milliseconds. We'll select Next, and now we'll browse to the network selection And there we see a list of all of the OPC Systems.net tags available in that remote service, and also the direct OPC interface. This we could also use in the HMI and trending controls as well, as we had just previously demonstrated. With the direct OPC interface, now what we're doing is we are browsing the OPC servers in the OPC system service, and so this way your OPC client can actually create the tag directly without having to create an OPC Systems.net tag in the real-time database. Here I'm just going to browse to this simulator OPC server, double click on that point, and select Next, and done. And now we see that when the value changes, and now we see that we are subscribed to that remote OPC server from that remote network node, still using a TCP connection without using Decom to do the networking. Let me also add another tag to a OPC Systems.net tag. So there we have the two items in this subscription, and we see that the ramp2 signal has a shorter tag name because it's just ramp2.value, where the other is using the full direct OPC interface to connect directly to the OPC server. So that's how to connect from a third-party OPC client over the network to a remote OPC system service. If you wanted to connect from an OPC server to another OPC server over the internet, we can use the product feature OPC route.net. This allows us to specify to connect one OPC server item and automatically transfer that value to another item. That is defined under configure tags. I'm going to configure the local service here, and I'll add a new tag. I'll use the tag name A so it appears at the top of the list. I'm going to use the data source of tag. You could also use the data source of calculation or the data source of OPC item if you also wanted to use the product feature OPC client.net. This would have the benefit of being able to write back to the remote service if you were going to use the data source of OPC item. With the tag data source of tag or calculation, it becomes a read-only tag. Now I'll select Browse. Instead of using localhost to browse for a tag, I'm going to include an IP address, network node name, or registered domain name. We'll hit the select button. I'll choose the ramp value signal, and you see that it has the same exact path structure in front of the tag for the remote network node name. We'll click Apply Changes just to check the data source of that value, and we see that now it's coming in with good quality with a value. Now we'll move over to the Target tab, and this is where we're going to enable an automatic write to another OPC server. So we only need this feature for automatic transfer from one OPC server to another, or maybe we're using a calculation as a data source to network multiple items together into one common value and then send the result back to an OPC server. Now here we're always going to select a local OPC server. We do support remote Decom, but for the easiest connection you'll choose the local OPC server. And let's just choose an output item. I have some output signals under out test here, and I'll choose output 11. And now I click Apply Changes, and we're done. So now we're connecting over the internet to this remote service under the Value tab and automatically writing its value to the local OPC server here. If you want to remotely connect data into Microsoft Excel Workbook, you can use the product feature OPC Excel.net. Just open Microsoft Excel and then use the OPC Systems.net OPC Excel Wizard application. You can find that under the program group OPC Systems.net and then the program OPC Excel. This is a browser to connect to either a local service or a remote service. Again, what we'll do is just define an IP address or network node name in the network node field. I'm going to use that remote connection over the internet to that system in Texas. and select the item that you're interested in. Again, the exact same tag structure that we were looking at earlier with any of the HMI applications or the OPC route feature. We'll select to copy this formula to the clipboard. That button is in the lower right. And now just paste that formula into your Microsoft Excel workbook. We are now receiving live data over the internet into this Microsoft Excel worksheet. So you can simply save this workbook, copy it to any system, as long as you've installed also the product OPC Excel.net on that remote client computer, and then when you open this workbook, this data value will appear. You can also use this to write values back to the OPC system service as well. We have a different product video on OPCExcel.net that you can learn about more features there. But you can see that networking is very simple into the Excel workbook to simply include the node name, IP address, or registered domain name in the tag name that you're connecting to, and let OPC Systems.net networking do all the work for you for bringing that value across. Remote configuration is very simple. I can go to Configure Tags to demonstrate this with the Configure OPC Systems application. And instead of connecting to the local host, I'll connect to a remote service. I'll hit the select button, and now I am browsing the tags on that remote system over the internet to the system in Texas. I can select any of these tags and see any of those properties. Now this particular service has security restricted in it. So if I attempt to write to one of these items as far as updating it, I'll get this message that says invalid security access for obtaining tag parameters. So I would either need to log in with the appropriate authentication or remove the security from the service itself. So we can use this technique to define to a remote network node name with all of the configuration attributes. That would include data logging, alarm notification, reports, recipes, the UDP broadcast feature, security configurations. Those can all be done remotely from your OPC Systems Configure application. You can also use the free-to-use programmatic interface to define all of these configurations from a .NET application that also supports remote connectivity. We can see an example of that under the WinForm example code, and I'm going to bring that up so you can see where it is that you would define that remote network node name to connect to using the OPC Systems component. Let's use one of the more popular methods found under the form configure CSV to programmatically define tags using what is called a comma-separated variable import method. So if we scroll down a little bit, we see the tag CSV import method on the OPC Systems component. And we'll see that the first argument is all of the tags and parameters with the values that we want to import to the OPC System service. The second parameter is the network node name, and that is where that could be an IP address, registered domain name, or network node name of a remote OPC system service that you want to configure. So you will see that all of the OPC Systems component methods have a network node field. Here it's optional, which by the default is localhost, but if it's included, it will instead redirect to that remote service and make the call to that one. So you can see that remote configuration is very simple with both the manual and the programmatic methods. Let's set up some remote data logging with the Configure application. I'll put in a new logging group name, make it active. You can choose continuous or event driven, that's up to you. When I define the tags that I want to log, again, instead of selecting localhost, I'll include a remote network node name and hit the select. I'm going to use a local node on my network here called OAS Vista PC and browse to a tag on that service. Again, you can also use direct OPC if you'd like as well. Same tag designation, it just includes double backslash and the network node name backslash in front of the tag name. Now when I put in my field names, I can make the field anything that I would like. And that is all we need to do. Now you can right click in this list to do a CSV import and export and connect up the rest of your tags. Now we just define where it is that we want to log that data. I'm going to use my local SQL Server node to log to. We can also log to CSV files. I'll put in a new database name and a new table name. and I'll add that to the configuration. Now we are logging data from that remote service node with these tags into that database. Now you're also welcome to include a remote SQL Server or Oracle node using the Oracle client connection to log to a remote database engine and just have local tags. They could also be remote tags, so you could go from remote tags to remote database engine and kind of use it as a pass-through. That's completely valid to do that. The reason I say it's okay to do also the remote database connection because we have buffering that's available for both the data source and the data destination. So if we have a database engine failure or network loss, we would be buffering that data in all setup types. By simply going to configure options, we can enable the property called store data logging buffer to disk. About 3/4 of the way down, we'll see a area called data buffering, and we have this checkbox called store data logging buffer to disk on network loss or database engine failure. You then simply specify a directory on your local hard disk to buffer to when either you have a network loss or database engine failure. So in either setup of monitoring remote OPC system service tags or logging to a remote database engine, as long as we have this feature enabled on all of the services that we're logging from or actively logging to, then you will lose no data on a temporary network loss. The same is true with the alarm logging. Alarm logging is very simple to set up. Under the node selection of the alarm logging, instead of using localhost, you'll add a remote network node name or IP address or registered domain name. We'll do the same thing with alarm notification. We again have the nodes tab, and this is where you would define the remote service where you want to do the alarm notification via email. Now with this type of setup, if you have a network loss, your email will not go out if you lose the network connection. However, if we're using the tags attribute to keep track of how long something's been in alarm or how many alarms have occurred over a particular time frame, this will always be accurate even if we have a temporary network loss. Of course, it's not available during the network downtime, but when the network comes back available, we will be able to have an accurate reading of all of this. Now let's review remote OPC connections. We'll see that the best implementation is to take advantage of the OPC system service as a service-oriented architecture to have all OPC Systems.net tags or direct OPC items always connect to a local OPC server. That's your best option as far as reliability and ease of setup. So when we're setting up an OPC Systems.net tag and we have the data source set to OPC item, when we're using the browse selection, we'll always choose local to define to a local OPC server to get that local OPC item. This way, if your network drops out, you still have a local OPC item connection. Now it is possible to use remote Decom also with OPC Systems.net. There really is no advantage to doing this. In fact, there's a lot of drawbacks to doing remote Decom. But we support it just like a lot of the other SCADA packages out there do it. But if you do it this way, you have then lost to do data buffering for both trending, alarming, and data logging. So if the network drops out, you've lost that connection because it won't be able to connect to the OPC server. Let's see what that would look like, just in case you were interested to see what it is. So here I'm browsing a remote network node name, and I'll select to that ramp2 signal. And we see that it includes also the network node name with double backslash in front of the OPC server and item name. But again, not really the best way to do that, because then you've downgraded your reliability of your system. If you remember these points we were talking about, it's difficult to set up a connection, no data buffering, there's no support for internet connections over remote Decom, and if you do want to move forward with remote Decom, let's say your customer says, I absolutely cannot install any other software package on the system where the OPC server is, then you have no choice than to use remote Decom. Then we have a setup guide that you can use to set up your network for remote Decom. So if we look under the downloads page, we have this OPC Decom setup instructions. So we have a PDF file that you can download from this right here. I'll go ahead and open that up for you. So this is a Decom setup guide from the OPC Foundation. It's a 14-page instruction manual on how to use remote Decom. So you'll see that, wow, it was probably a lot easier to just use the OPC System Service Networking to make the remote connection. Now if you wanted to see some live examples of the remote networking of OPC Systems.net in either a WPF or Windows application or even a web application for your smartphone, you can go to the online demos link at the bottom of our main page at opcsystems.com, and here you can run a smart client example connected to that same system I was connecting to earlier in Texas. And from your smartphone, visit the website opcweb.net. It'll bring up a nice web page where you can browse the HMI controls, the live trending examples, and live alarming. We have more training videos on each of the product features of OPC Systems.net, not only the ones that I covered, but also other product features of the full OPC Systems.net suite. Under the training page at opcsystems.com, we have those online videos. Also, under the downloads page is where you can download OPC Systems.net for a free 30-day trial. All existing users of OPC Systems.net, dating back to the original release in 2004, support the networking that we've just described. So the networking has always been easy to implement with OPC Systems.net over a binary TCP connection. Under the Contact Us page, you'll find our contact information where you can request a free product demonstration, and we would be happy to describe any of these networking features in more detail, but it really is just as simple as we've demonstrated in this presentation video to simply include the network node name, IP address, or registered domain name in front of the tag name when you're connecting to the HMI, trending, OPC client features, or routing items, or the alarm network node when you're using any of the alarming features.